Welcome to the Zack of all trades family homestead project. First episode. Today, I hope to show you how to locate water using some plants and some bent wires. Ooh, the dreaded bent wires. So, the bent wires. Let me go ahead and address this. First things first. There is no witchcraft involved here. I am not summoning spirits of the earth in order to move these bent wires. I'm not hoaxing using these bent wires because what would it benefit me? I am trying to find water for my homestead to irrigate or potentially to have potable water for our home. What good would it do me to manipulate these wires to make it look like I was finding something? It's not going to do me any good. I am not a spirit worshiper. I am a Christian. I have no interest in harnessing evil spirits to move some wires. Let's talk about what might make these wires move. Every cell is made up of atoms, right? Every atom contains positively and negatively electrically charged particles. What happens when you move electricity, positively and negatively charged particles? When you move electricity, you create magnetism, right? You remember when we wrapped in high school or grade school, I suppose, when we wrapped a wire around a nail and then hooked it up to a battery, that electricity flowing through it created magnetism. So within the planet, and I'm going to be the first to tell you, I don't fully understand how this whole wire thing works, but it's not so much of a stretch to me to believe that within the planet we have moving water, right? Water, even though it's water, it's made up of electrically charged particles, and when those particles move, it creates a different magnetic field. Now, all I have here is two just steel, I think they're steel, wires. Piece of fencing wire that I cut and bent a handle in. So what I'm going to be doing, I'm not summoning spirits. I'm not just trying to fool you into believe something. And truly, I don't even know if this is going to work. So if you're interested in finding out, come on along. If you're going to throw into the comments what hogwash this is, just go ahead and hit stop right now because, well, I'm not interested in it. So, with all that out of the way, let's talk about the plants. Sometime back, while reading a book called Back to Basics, an old hardcover, big old Reader's Digest book, which, if you can find it, I'd recommend picking it up. It's really cool. There's a lot of stuff in there. But, beside the point, in that book called Back to the Basics, there's a tiny little section about water indicator plants. Plants that require X amount of water or require water in thus and such volume to be so close to the surface. Now, I don't believe that it gives exact figures. I think it gives some roundabout figures for distance between the surface and the water table. At any rate, one of those plants is elderberry plants. Where you find elderberry plants, supposedly, I have not yet proven this for myself, but where you find elderberry plants, you should find water within 10 feet of the surface. One of the things that I have completely put together out of my own brain, out of my own surmising, so I don't know whether it's correct or not, is that you can read a lot from the plant itself, assuming that an elderberry bush requires a fair volume of water within 10 feet of the surface. We'll just assume that that's true because it's been corroborated in a few different pieces of literature that I've found. So assuming that that's true, what can we learn from the plant? This plant is not terribly big, and around its base there are no dead versions of said plant. To me, what that means is that this plant is probably fairly young. It could be fairly young for a couple of reasons. Either one, it could have recently been seeded within the last few years. It could also mean that the water source that an elderberry plant needs is recent. Maybe the path that the water takes has recently been disrupted by who knows what, and this is a new water source. Now let's look at another sort of elderberry plant that you might find. Big, tall, fairly wide trunk. But what's more important that we need to look at is at the base of it. And again, this is not anything that has been proven by anyone that I'm aware of. I don't know, it just seems to make sense to me. You have here on the ground all of these dead trunks from this same tree. Now, it seems to me, if you have that, that seems to indicate maybe that this water source seems to be pretty good because it's got a pretty sizable tree on it, but there's dead ones all over the place. So does that mean that in the super dry years that this water source dries up? And then you have the other sort, like this one on some family of mine's property, that is just a tree. Pretty clearly shows a consistent, solid, year-round, every year water source. There's no evidence of this tree having ever died off. Today I'll be trying to find water at the base of this well-established tree with the dead trunks around it. This is a fairly wet year, so if there's going to be water there, I should be able to find it. Let's hope so. Now let's talk about these wires, what they are and what I'm going to be doing with them. These are purely, look at the end, they're just galvanized steel wires. Coat hangers work just as well if you can find old wire coat hangers and just cut out a length of them that you can make a bend in. That's what the wires are. They're nothing special. They're not perfectly straight. In fact, they're just kind of wires that I bent an L in. So how I'm going to hold them doesn't matter really how you accomplish this. This is just kind of how I hold them. What you need to do is you need to have them pointing a little bit down so that their natural resting position is forward, right? Because gravity is trying to pull them, pull that forward. If I have it perfectly level, I don't know if you can see it here, yeah, if I have it perfectly level, it might go all over the place. So what I need to have them set in a forward attitude. I need to have as little resistance here as possible. I don't want to be holding them. I don't want to be, gripping the heck out of them. I've heard of people taking a hollow piece of pipe or something like that, a piece of plastic pipe, and putting them in, which seems like would work. I've never done it myself, but so here's how I'm going to hold them. I'm just going to hold them like so, and then I'm going to walk across where I suspect there might be water, and I will watch what they do. Over here is this elderberry tree. Sorry about the squeak on the tripod. I'm going to come back here. I'm going to walk where I think there might be water. I'm trying to cross it perpendicular. When I get to where the water is, you see them go out? Okay, they're going out. So they're going out right about here. So I'm going to put a rock right in that spot to mark what I think is the edge of the water flow. Now I'll do it again in a couple of more places because I want to establish a line of where I think that water is. Okay, another rock here. Another rock here. Now about these wires going in or going out business. I tested this pretty heavily with a garden hose. Now I know you say a garden hose is not like finding water underground. True story. With me holding these rods, when I walk across a garden hose that is full of water, that is not moving, the wires will go inward. They will cross inward just over the garden hose. As I add wraps of garden hose, like I went kind of back and forth about 3 times, does the same thing. When I turn on the water, or when I open up the nozzle at the end so that water is flowing, for me, when I go across that water hose, the wires go out. So what I've gleaned from that is that the wires go out when there's moving water, and they go in where there's still water. The other thing that I've determined is that when I walk down parallel over the top of one garden hose with water in it, still water, my wires cross about that much. When I double that hose back on itself so that I have 2 hose widths of volume, still water again, my wires crossed about that much. When I did it 3 times, my wires crossed about that much. So what it seems to indicate is that the more volume there is, the more severe this cross is going to be. Now, with 1 hose of moving water, it crossed about like that. So how to exactly interpret that, I don't quite know, but I'm learning as I go. Okay, I've now walked it a few more times, and I've placed rocks here, here, and here, and it seems to be about, what is it, about 4 or 5 feet wide, because I also have placed rocks at edges here, here, and one up there a little bit further. So it seems that the flow goes right through where the elderberry tree is and continues this direction. Now, just in case this works, I have to make this statement that there is neither upstream nor down theoretical stream of this place where I'm going to dig. There are no wells, there are no springs. I'm not tracing a water flow, tracing an already known water flow, and I can't really prove that to you. You're just going to have to believe me on that. Now the next part comes trying to find depth, where we should expect the water to be. Now, what I understand to be the way to find the depth is to get right in the middle of your water flow where your wires should be pointing out, straighten them out so that they're forward, and then walk forward. Eventually, they'll go out again. This distance from where they went out to the center of my water flow should be the depth of where I find water. Again, this is all kind of experimental to me, so it might work and it might not. I hope it works. So now I figure I've got water 1, 2, 3, 4, 5, 6, 7. Seems like I've got water about 7 feet down there. I don't know if this is going to work because I don't know if my digger reaches 7 feet. And now the digger. Here is an old school digger. I have seen these for much of my life and had no idea what they were actually for until recently I learned that this is for digging holes. Maybe for searching for water, right? So here goes. I'm told that these are best used in sand or gravel or dirt, but not rocks. They're not going to do much good in rocks because it seems to hang them up. I've never used this before, so we'll all be finding this out at the same time. Here goes. This 7 feet might take a while. Well, I've hit rocks at the bottom of the hole that my digger won't get past or through. I'm not entirely sure what I'm going to do just yet, whether I'll come back with a bar, a pointed bar, see if I can break the rocks out of there, or I may just go dig at another spot that I've been prospecting. If you find yourself out digging a hole in the middle of somewhere, you need to walk away from it for the sake of the people and the critters alike. Put something over the top of it. You don't want anybody breaking their leg off, do you?